Hello, my name is Irene Kwong, and I'm a PhD student at MIT. Today, I'll be sharing my work on building handheld magnetic resonance imagers. While clinical MRI is a very powerful and non-invasive diagnostic tool for getting high-resolution images of our body's internal organs, these systems are very expensive and require a lot of infrastructure to set up and maintain. So my work is targeted towards building a system that is both portable and low cost in order to improve accessibility to MRI in point of care diagnostics and in classroom education. And what you'll see is that all of this work can even be done from here in my apartment bedroom. The first step in this process then is building the magnet. Inexpensive, commercially available bar magnets like these can be arranged in an array so that we can obtain a magnetic field that is uniform enough for imaging. This magnet, which I can slide my arm into, has been optimized for a uniform field. It's easy and safe to assemble by just sliding bar magnets into a 3D printed enclosure. We also have a smaller version of the magnet that I'll use for some demonstration here. The next thing we need in our system then is a method for generating magnetic resonance signals. To do this, our research group has developed some low-cost tools to generate and receive radio frequency pulses needed for imaging using a microcontroller and a $30 ultrasound programmable integrated circuit chip. The pulses are sent to a coil that's placed inside the magnet, and the coil transmits and receives the MR signal, which I'll read back into my computer. First, I'll try acquiring a signal without any sample in the magnet. The received signal plotted here shows the two radio frequency pulses generated by our signal chain, but no MR signal, which we would call the spin echo. So now I'll place a sample test tube of water inside the magnet. In the human body, the protons in water are what generate signals that are picked up by an MRI scanner. And here we have a spin echo. So now that we have a magnet and the electronics for acquiring basic MR signals, the next question is, how does this translate into imaging? So in a typical MRI scanner, coils generate different field patterns within the magnet to be able to spatially discern structures within a targeted imaging region. Because the magnets I'm working with are much less uniform than a clinical MRI, this method is not easily achievable. Instead, what we've noticed is that changing the magnet geometry by performing small tilts on several axes can generate field patterns that can be used for imaging in handheld MRI that anyone can build.